we have discussed number systems, conversion and complements. So now we will pay attention towards range of numbers which can be represented. Range of numbers which can be represented using complements representation. Okay, go ahead for that particular thing. Let me take a very basic example, if not very basic scenario, to understand it clearly. 0 0 0 1 1 0 1 1. Then I will map it for a 3-bit thing. Okay, so in terms of a 2-bit one, this is a 2-bit code, and in terms of unsigned representation, in terms of an unsigned representation, plus 0, plus 1, plus 2, plus 3, a straightforward scenario. Okay, now when I put this in terms of complement representation, so complement representation, I have 2's complement and 1's complement representation. Okay, I am first writing their complements over here as it is, and then I will represent what does that particular number represent. Sorry. Now 0 0, 2's complement is again 0 0. 0 1, 2's complement is 1 1. 1 0, 2's complement, if not, instead of writing that, hold on for a moment, instead of writing that, what does this number represent in terms of 2's complement and 1's complement? Let us pay attention towards that one. So once we have the number representation 0 0 0 1 1 0 1 1, in terms of unsigned number representation, we directly consider its magnitude as the corresponding number, and it is by default a positive number. So that's the reason we are calling it as a unsigned number. Okay, now going ahead with the signed representation. There are many other things corresponding to signed, but we are trying to focus upon complements as of now. Then we will focus upon the other things. So as far as signed complement representations are concerned, now when you see this number, I will call it as plus 0 only, represented 0 0. This is called as plus 1 only. Now here you need to pay attention towards what is that is, whenever you are trying to represent signed numbers, that too corresponding to complements, pay attention towards the MSB. And if that MSB bit is 0, consider that it is positive. If that MSB bit is 1, consider that the number is negative. Okay, now we want to know what does this number, what does this representation, or what does this bit combination 1 0 represent in terms of 2's complement representation. So 1 0 is what is the case. Now as soon as you see the MSB, it gives you a hint that it is a negative number. It is a negative number. Now you put it this way. Negative number means this number is wearing a mask. This number is wearing a mask. You can remove that mask by applying 2's complement only. Apply 2's complement and remove its marks. But interestingly for this scenario, if you remove the mask also, it is 1 0 only. Meaning to say, when you remove the mask, it gives you the magnitude. When you remove the mask, it gives the magnitude. This magnitude is 2. Since you have removed the mask, this number is minus 2. Now come out to this one, 1 1. Okay, might look a bit confusing at the initial instant, but it is not. Pay attention towards, then it will be easy. So this is a number. What is the MSB? MSB is 1, meaning to say it is a negative number. Negative number means what is that we are supposed to do? We are supposed to remove its mask. Remove the mask. Remove mask. Okay, remove the mask. Remove the mask means apply 2's complement to that number. When you apply 2's complement, this number, what it will be? 1 0. So what does this number 0 1 represent? When you remove the mask, you will get the magnitude of that number. When you remove the mask, you will get the magnitude of that number. So it is 0 1. So magnitude is 1. Since you are removing the mask, it is minus 1. So that is the case. So the way in which you remove the mask is, for a 2's complement, you remove 2's complement way, 1's complement, 1's complement way. So that is how it is calculated, and you will know what does that particular number represent. Now go ahead with the complement. 1's complement representation, MSB bit 0, so it is positive, so you need not have to worry, plus 0, and this is plus 1. Coming out to 1 0, 1 means this fellow is wearing a mask, negative number, so this fellow is wearing a mask. So what is that I am supposed to do? 1 0, it is wearing a mask, so remove that mask by applying 1's complement. Apply 1's complement to this number. So what does it become? 0 1. What is the magnitude? 1. So this is represented. This number, this combination in terms of 1's complement represents minus 1. Now come out to this one, 1 1. So 1 1, this number is also wearing a mask. Remove the mask, it becomes 0 0, and since it is, you have removed the mask, you will write it as 0. 0 0 magnitude is 0, so this is your negative sign. So this is one limitation when you consider, if not one setback as far as your 1's complement representation is concerned. You have plus 0 and you have minus 0. Multiple representations for 0, so not that much encouraging. So mostly 2's complement representation is what is like followed as far as system implementations and all that are concerned. Okay, so more attention towards 2's complement, but still we will have an idea like what does a number represent, how to calculate its particular value in terms of 1's complement and 2's complement. Okay, so for a bit more understanding, I will try to list out our 3-bit combination also. Why? Because unless and until you understand this one, like many times there were questions on complement, so I don't want you to have any confusion as far as those number representations are concerned. Okay, so let me represent that 3-bit combinations also. Right, going ahead with 3-bit combinations. So 3-bit 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, first let us write unsigned representation. So it is plus 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 and plus 7. Now on the other hand, we have signed representation. There are many things in terms of signed representation, but at this point of time we are trying to refer on to 2's complement and 1's complement representations. Okay, 1's complement representation. Okay, so in terms of 2's complement representation, what is that we can write out in a straightforward way? In a straightforward way, we can write out the combinations for which MSB bit is 0. Since the MSB bit is 0, this bit is 0. So that's the reason all these are positive numbers as far as complements are concerned. All these numbers are 1. So these are negative numbers as far as complements are concerned. Okay. So now, as far as complement, now may I write these things? Yes. These are straightforward, plus 1, plus 2, and this is your plus 3. And this also same, plus 0, plus 1, plus 2, and this is your plus 3. Now, you have to be a bit careful, if not be attentive while writing these things in terms of 2's complement and 1's complement. Is this number is wearing a mask? Yes. Remove the mask. I need not have to write it separately, but still for your understanding. Okay. This fellow, when I remove the mask, when I remove the mask, what will be its corresponding value? 1 0 0 again, meaning to say magnitude is 4, so I write it as minus 4. Remove the mask of this number. When you remove the mask of that number, 2's complement is 1, this becomes 1 and this becomes 0, so it is 3, so this number is minus 3. In the similar way, remove the mask of this fellow, 0 1, this becomes 0, magnitude is 2, so it is minus 2 and this becomes minus 1. Okay, so that's the case as far as 2's complement representation. Now as far as 1's complement representation is concerned, 1 0 0, take complement of that particular thing. 1 0 0 complement is, I am using another marker for that, 1's complement for easy understanding. Okay, now what is 1's complement of this fellow? Removing mask of that particular fellow, it will be 0 1 1. Okay, 0 1 1, magnitude is 3, so this number represents minus 3. So this is your minus 3. And how about this one, 1 0 1, 0, 1, 0 magnitude is 2, so it represents minus 2, and this is your minus 1, and this is your minus 0. These are the numbers. Now time to conclusions, time to take home points. What are the take home points out of this one? We'll write the range. Let me erase this one. Looks very interesting and very important as far as examination is concerned. Okay, range of numbers. Range by 2-bit. Let me consider that it is 2-bit. Okay, 2's complement and 1's complement. What's the range with 2's complement? 2's complement, the range is minus 2, 2 plus 1. 2-bit representation. 1's complement minus 1, 2 plus 1. Okay. In the similar way, what's the case as far as 3-bit representation is concerned? As far as 3-bit representation is concerned, 2's complement, it is there on the board. 1's complement. Okay. So 2's complement representation, the range is from minus 4 to plus 3. Minus 4 to plus 3. And 1's complement representation minus 3 to plus 3. Hopefully the things are clear. So now here we will summarize. Okay. Yes, we can summarize it here only. N bit, using n bits. Using n bits. So this is a notch. Using n bits. Range for 2's complement. Range for 2's complement is minus 2 to the power of n minus 1 to 2 to the power of n minus 1. You can write it as plus also, but I just written it as minus 2 to the power of n minus 1 to 2 to the power of n minus 1. Minus 1. I'll write it again rather than, it looks a bit clumsy over there. Can erase this one. Sorry. Right. So the range of numbers looks something like this. Using n bits, it comes out as 2's complement for 2's complement. This is for 2's complement. Minus 2 to the power of n minus 1 to 2 to the power of n minus 1 minus 1. Why? Because see, n is equal to 2. When n is equal to 2 here in this scenario, n is equal to 2, substitute the same 2 over here, 2 minus 1, it is 1. 2 to the power of 1 minus 2, 2 to the power of 2 minus 1 is 1, 1 plus 1. So minus 2 to plus 1 in a generalized way. And using 1's complement. Using 1's complement, what's the range? These are take home points. Right. Using 1's complement, what is the range? Minus of 2 to the power of n minus 1 minus 1. Why? Because it is starting from minus 1 to plus 1. So 2 to the power of n minus 1 minus 1. This is a range of numbers which can be represented using 2's complement and 1's complement. That is n bits. Using n bits, those are the numbers which are represented.